Welcome everybody. Thanks for taking the time to join us this afternoon. Jen, if you could click us through to our first slide. So let's just take a look at today's agenda. So our presenters for today are John Davis and Neil Saunders. And in this session, they're going to be talking to you about manufacturing data, so typical data sets and flows, the benefits of being data-driven, and some of the challenges to achieving that. They'll touch briefly on ways we can connect and integrate to different resources and third-party systems to create an information-rich environment before looking at different approaches you might want to take, so taking into consideration some of the current issues you might be experiencing. So bringing that all together, and most importantly, John will then give some examples of how different departments can make best use of your manufacturing data to take positive, informed action and basically go over how we can help support you through the process. So throughout the presentation, you'll see screenshots of our app, our scheduler and manufacturing execution software modules, so the Seeky Scheduler and Seeky Air. We won't actually be including any live software demos today, but after the session, if you want to let me know that you want to see a demo, I can get that booked in for you. So on that note, I think it's time to hand over to John to kick us off.
Thank you, Jamie. So just to start initially to talk a little bit about what data-driven manufacturing is. So it's talking, or we're considering here data that you may or may not already have available, and turning that data into something useful so that you can drive improvements in your business. So this might be in terms of some displays around the factory to give you visibility. It may be looking at historical trends. There's a whole amount of data, but what we don't want is the data that you have, if some of it's manually generated, just to be in some data warehouse that really doesn't help you improve your business at all. So the data that we're talking about and that we're going to be concerned with in this section needs to be accurate. It needs to be validated. It needs to be available once it's been collected as quickly as possible. And it needs to be easy to access and share across the organization. Now, we're going to come back to these later, but the important point here is that you'll see during the presentation, some of the discussion, that we have tools that help you ensure that the data that you do collect conforms and is aligned to all of those 4 bullet points that I've just displayed on the screen now. So the challenge is often the lack of available data, or even if you have the data, how you can use that data to help you improve your business by making some sensible decisions quantified by the data that you've collected. So a good starting point, and this came from a conversation I had with a customer only last week, was how do I know if I've had a good day? How can I measure that? What is a good day to me? Is a good day that I've had no problem on any of my machines on the shop floor? Is a good day that I have managed to deliver everything that I expected to do today? Or is a good day that I've actually increased my turnover because we've dispatched some high volume orders today? It'll be different things to different people. But the important thing is that you can collect the data and present it in a way that helps you understand if you've had a good day as soon as possible, maybe even during that day. So the data will help us form some decisions that may impact that manufacturing process, as opposed to it being on guesstimates or hearsay or people's personal opinion or a bit of a gut feeling. You may have a gut feeling that you have an issue in the business, but the data will help you quantify that. The data you may have might be unstructured. You might collect some of it manually. Somebody else, for sure, there will be people in your organization with spreadsheets that have the data, but how is that available to others? It may be in your ERP system or your financial accounting system, but it may be in different formats in different systems across different time zones. And then if we're going to move into the world of automated data collection, what about connecting older equipment together with more modern equipment? How can you get a uniform view across all of your plant? So what I'm going to talk about briefly now is where we have some potential data silos and different elements of different pieces of data. If we start with operations and finance, so you might use an accounting package, you might use ERP, MRP, you might use a warehouse management system. The data we're looking at here, bills and materials, works order operations, routings, material availability. That type of data. The reporting would predominantly, in that case, probably be financial. If we move across to the next step, where we're having understood what we need to manufacture and when we should deliver the work in our ERP or MRP system, how do we plan that through the factory? Many people use Excel and some very clever and sophisticated Excel spreadsheets, usually and quite commonly the domain of one individual. So if that individual leaves the organisation, the successor has an Excel spreadsheet that they haven't configured or understood. You may already have a planning system. That APS, Advanced Planning System, may be part of, integrated part of, module of your ERP system. But here we're looking at prioritisation of work, the resources that we're going to do the work on. The order that we wish to manufacture it, ultimately delivering a work to list out to people that are manufacturing the part. Delivery timescales, either for customers or to meet a shipment to onto a lorry at the end of the week or onto a ship maybe. The engineering team will probably be using CAD/CAM. They may well be using PLM, Product Lifecycle Management Systems. So we're looking at drawings, 3D designs, assemblies, tool lists, setup sheets, work instructions, the NC program that we're going to feed down to the machine if we have a machining environment. Often here we see a lot of paperwork. That paperwork can be distributed on the shop floor, and it's difficult to keep that paperwork then up to date. Once we get down to the shop floor, this is where we can start capturing some of the data. You may well have timesheets, manual sheets that people fill in to account for their time, what they've actually produced today. So, or you may have a shop floor data collection system. So the sort of data we're looking at here, works order batch cards, route cards, job instructions, and the status of the job. Is it running? Is it paused? How many have I made? Non-conformance issues. And the actual resource that we're performing the work on. It could be as simple as a manual bench where we may be doing some assembly or some deburring, or it could be a sophisticated machine. It could be a CNC machine, it could be a punch press machine, it could be a paint spray booth. But here we're looking at, is that resource working effectively? So how much time is it available? How much work have we got scheduled and planned onto it? And if it's not able to produce the work in the time that we expect, why is that? What are the downtime reasons? What are the issues that the operator of that machine is actually faced with in order to keep that machine and piece of equipment running effectively? There's a number of benefits that you can get by using the data, making that data more useful and usable. Some of them are on here. I'm not going to read the words on these bullet points, but hopefully you will have at least an inkling of some of these benefits, and hopefully that would be why you would be joining this webinar. And if you didn't have an inkling before, hopefully some of these will be clearly available and a little bit more obvious to you as we go through the presentation. So what I'm going to do is hand over to my colleague Neil Saunders. Is going to take us through some of the data flow so we can see how the data that I've just explained on the previous slide actually flows through your organisation and the systems and the type of people that may touch.
Thank you, John. So in the next section, we're just going to cover that data flow and the information that can be obtained from the shop floor and how we might use it. So on this particular slide, what is it that we mean when we speak about data flow? So data is used to connect people, processes and machines. By allowing the data to move efficiently between the office and the shop floor, you can achieve a seamless flow between the two areas. An example of this is from things like existing third-party ERP systems or databases, as well as exported files such as flat files like CSV files and the output of that data. So on the diagram on the screen, you can see that it's showing different types of data that can be imported and also output from potentially the CE scheduler in this case and its database via the CE AI module. So this third-party piece of software, our EAI, sits between third-party systems, and then once the schedule is saved, we can then send work queues out onto the shop floor to be synchronized with the scheduler. So that you have this production plan. It creates a prioritized work list for each individual resource, and that's all via this direct API between the two systems. With booking on the shop floor is then used via the shop floor terminals or tablets in the case of CKR, and it's used to update the status of the works orders and also the operations back in the scheduler again. So again, this uses that direct API between the shop floor software and the scheduler database. So all of this is then carried out sort of as near real time as possible. You want to have up-to-date information and be as accurate as possible at that moment in time. So the information that we collect can be output, and then it can be imported back into third-party systems such as your ERP or database. So we can give you that information back, and it can be taken back and written into your third-party system now. So this example sort of creates the workflow between the scheduling system in the office and the bookings down on the shop floor. So that's one form of the data flow. How do we collect the machine monitoring data? So how's that used? So there are different protocols that can be used, such as MT Connect, OPC, Planet Focus, to name a few of them. And this information can be passed via Ethernet if we're using one of those particular protocols. But where the resource doesn't have that capability, we can use hardware. So it uses digital IOs or signals from the machines via relays that are installed to each machine tool that can't process via Ethernet. So we can provide various statuses, so things like the machine's running, it's in an alarm state, it's idle, potentially possibly part count, and whether the machine's powered on or off. So additional statuses that can also be obtained if you're monitoring via Ethernet might be things like a non-optimal feed or a non-optimal speed. So has the operator been overriding the feeds and speeds and not running at its optimal sort of percentages? Non-productive statuses or losses basically are entered by the operator. So when the machine can't tell us why, the operator can enter the reason on the terminal or the tablet as the status as when the resource has stopped. So, you know, why has it stopped? Tell me why. Lamp stacks are a good place good thing to use in conjunction with the monitoring, as it can provide a visual status straight away, although there are screens that can display this as well. But you can see the status of the resource from maybe a distance. But they're also a good place to obtain signals when you want to use the hardware monitoring. So the green lamp, the red lamps, things like this to pick up the alarm and the in production type signals. So management of the digital data is controlled basically from the production office, and then that's driven down onto the shop floor. Production office can administer the creation and the management of the required manufacturing data for specific parts and operations. So they can create these packages of information. So, and that can be for specific machines that can use that. The information can then be made available to the operator at point of use on the shop floor. So they haven't got to go hunting for this information, it's there at their fingertips. Sort of information that this could include might be a picture of the part, setting sheets, tooling sheets, work instructions, and in the case of a CNC machine, the NC program for the transfer. We can access electronic batch cards with works order and operation data, and all that's available to view on the shop floor and in the back office. So again, no need to print out the routing. You might just need a traveller to go around with the job. So transferring the NC file to and from the machines can be via Ethernet, or it could be via serial RS-232 connections. And that's carried out from the shop floor screen. So you can pass that information and send that program, return it, and transfer that file all directly from the shop floor screen that you have access to. And the pack of information, or we call it a job pack, has also the visual statuses, such as the fact that it's proven, maybe unproven, or on hold, to make the users aware of how to proceed. So, for example, if it's an unproven job pack, they know to proceed with caution because it's an unproven program and they've not used it before and not done it. So just take a little bit of care while you're doing it. And things like on hold will ensure that the NC program can't be sent to the machine until that status has been changed. And that might be because there's a drawing change, or you might need to modify the NC program because of that. So you don't want anyone accidentally downloading it and using the wrong program. So in order for a data flow to be relevant, really, it should be a closed loop. So a typical loop will be what you see on the screen here. So initially, you're going to plan your work. So you're going to enter the orders into your ERP or your database, or possibly even a paper-based type of system. And then the orders are planned to meet the customer's delivery request. You then need to inform the shop floor. So you need to maybe, in some cases, print out work lists, run around telling people what to do, and the order in which they need to manufacture those jobs. So things like information such as the tool sheet, as we said before, the drawing, the program, and other relevant information needs to be given to the operators down on the shop floor in order to manufacture the part. So the next step would they would manufacture that item, and they would use all of that information that you provided, and hopefully they're going to work to the list of jobs in the order in which you've given it to them. They're going to do some sort of recording, and even if it's paper-based, then you would likely do some recording, such as the time it took to do the operation, any good and non-conforming quantity that's been booked, and possibly if you're on a handwritten sheet, it's probably less likely that you might record some non-productive reasons or losses. But as we said, this could be potentially an existing sort of electronic system, or it could be handwritten timesheets or some other form of sort of shop floor data collection that you might use. So if we are collecting things like the losses as well as the production time, and all of this is required in order to look at the bigger picture, really. So because by using that information, we can start to make improvements. So that might be things like identifying inaccurate set and cycle times. So you might use it to hone those cycle times back in your master routines and become more accurate with your planning by using more accurate times. You can see where the losses are being booked. So, for example, waiting for inspection tends to be quite a bottleneck in most companies. Multi-manning of machines might be another one that's becoming more relevant nowadays. And whether the machine's in maintenance, or how much time does it potentially spend in a maintained state, and start to highlight that sort of information. And you can start to use this information then to better plan the workload, reduce those losses, and start to enter accurate efficiencies and lead to more increased productivity by being more efficient in the way that you carry on and do this. So the loop would then close and you're going back around the system again. So I'm just going to hand back to John, who's going to take over for the next part of the presentation.
Thank you, Neil. So I'm going to talk a little bit about connectivity and integration now, and to do that I'm going to start by talking about the data that a system may use that is going to provide eventually those valuable insights that we've talked about, so you can improve the process. So this is the type of data that we would typically be using in our MES system. You can see on the left, really the mandatory fields is the minimum amount of information that we would tend to read into our system in order to ensure that we've got accurate and validated data. So if you remember back to one of the first slides, we're not really intending to allow people to arbitrarily enter data into our system. We want it to be validated. So in order that people book onto a valid works order number, we need to know what the works order number is in the first place. So things like the works order number, the due date, the order quantity, plan time, setting and run time would be the minimum sort of data that we would probably be using to validate the data that we're collecting. There's some other optional data, for example here, things like customer. So some of you, especially if you were subcontract engineering, the customer may be relevant, very relevant to you through the whole life cycle of the works order. Other companies may literally be making for stock in the warehouse and not really have any visibility of who the end user customer is. When we're collecting data, then within our own system, we report on all of the data you've seen here, but you may well want us to pass data back up to the likes of your ERP system, in which case we can be sending operation times, quantities, when things actually started and when they finished. This is some examples of some systems that we've interfaced to. It's not exhaustive. We have a very configurable piece of middleware software that enables us to talk to a whole variety of third-party systems, be they ERP, MRP, financial or planning and scheduling systems. But just these are some of the systems that we've integrated with. And when we come to collecting data from resources, then here you can see a whole list of, typically these are NC or CNC machines that we connect to either using a network cable or via the small box, the photograph you see on the right there, to collect some digital I/O. So if it's an older legacy machine, it has no network capability, we can wire in and try and understand whether it's running, whether it's stopped, maybe whether it's got an alarm condition. So how do you start? It's all very well us talking the theory here, and I'm sure you will all be collecting and maybe using data to a greater or lesser degree. So how do you start? Well, I guess there's two main approaches. One may be a wholesale change. So you decide that you want to more effectively plan the work through the factory. You want to understand exactly what the resources are doing. You want to know exactly what's happening in terms of operation time. So that's a significant project. But it may well be that you have some legacy software that's being developed in-house and you have to change the whole system. It's not of the type of system that you can change in individual elements. Alternatively, you may be a bit luckier and you can adopt maybe a modular approach. So you might decide, well, you're extremely concerned about on-time delivery performance, and you may wish to start by looking at how you plan work through the shop more effectively. Alternatively, you think your planning is optimized, but the efficiency of your resources is pretty poor. So you may start with machine data acquisition. So I'm going to hand over to Neil. He's going to talk you through how we can address those individual areas. The key point here is that each screen that Neil is going to discuss really is a module of our system. So you'll see how you can just turn on individual modules or purchase individual modules as and when you need to.
Thanks, John. So in this part, we'll be highlighting some of the most common areas and problems that we come across in discussions with our customers, really. You might recognise some of these, or hopefully not all of them, but potentially maybe. But the idea is that by identifying those most critical points to address first, you can start to understand the problems that you have and start to begin to implement the changes needed to reduce these losses and other sort of data flow issues and increase your productivity. So production planning is obviously a key area to ensuring that you get an optimal flow of work through the company. So depending on the current methods that you might use, it can be quite laborious and time consuming potentially. There may be a need that, and some of you might take data from an existing sort of planning or ERP, MRP system and then take it outside of that and manually manipulate it to create some sort of schedule that you might work to. And some of those sort of external planning methods might be things like Microsoft Project, spreadsheets, or even things like a T-card system or a magnetic board that you might use. So there's a number of different ways that people do it. And maybe you use one of those now to support your ERP, really. These methods can significantly reduce the sort of flexibility of the planning capabilities that you might have, as having to manually manipulate all of the works orders and operations. It's quite an unwieldy and time-consuming practice if it's not doing it for you. So that can also lead to missed deliveries because the consequence of any changes that you make are not immediately recognised, and you can lead to decisions being made without sort of the full details of those implications. So having the right information available to you to make those decisions is a key thing. So by interfacing the data from your ERP, MRP or works order system and then bringing it into the Seeky scheduler, you can achieve a lot of benefits in the flexibility and the speed and the information that you can gather by understanding, what it is that you want to actually control and making those decisions. So minimising the administration time for the scheduling, being able to display the consequence of any changes that you make so that you can make an informed decision from it. Visually displaying early but more importantly late works orders, so getting a heads up in advance as to where there might be a problem. Being able to access your capacity and utilisation figures and having them at hand. And the combined outcome of all of this is really to provide an achievable production plan and look to try and ensure that you achieve those delivery dates that your customers are requesting, which at the end of the day all makes for a very happy customer. Control of the works orders and the operations and how we perform is another key area, really. Driving the work list to the shop floor can be cumbersome. Sometimes it can be, as we said before, printed lists. It could be work travellers placed in an order in a pile and you take the top one next, or even word of mouth where someone like a supervisor or a production manager hands out the next job so that the operators have got to go to them and find out what their next job is. Knowing the status of the works order might be a physical walk around. You might have to physically walk to that resource, that machine, or go and find that job and see at what stage it's at. So all of this can lead to slow communications between the shop floor and the office. So what happens if the next job, you give doesn't match the priority list? What happens then? How do you understand where you are? Because this can lead to the operations all being started in the wrong order, people cherry picking, for instance, and deciding what they prefer to do. And it's all additional time spent gathering the information needed in order to get that job changed. It can also lead to information not being available. So things like, have you got available capacity, or have you got non-conforming parts being created and manufactured? And you want to know about all of this. So using things like an electronic work queue and in our case what we call a WIP booking, CKR WIP booking, it can all help. It helps to reduce the inefficient methods of communication. It helps to deliver the required data to point of use on the shop floor more efficiently. It makes sure that jobs are booked and started in the correct order if the discipline is to work from the list top of the list down and only change if you really have to for some reason. It allows you to book things like good and non-conforming part quantities and a reason that it was non-conforming, like a piece of text or a code that you understand. You can adhere to those planned priorities because it's there, it's in front of you, and it's being synchronized with the schedule. And it allows for more accurate sort of capacity evaluation. Have you got the capacity to take this job on, or can you do this job because you've got a place and a holder for it? And it also can help provide the feedback loop to the planning system, so it keeps the planning system updated as a bi-directional through that API that we mentioned at the beginning. So being able to get an overview of the resource statuses, the production losses, the time taken, it's all important information to help you reduce those losses and become more productive. So some of the things that we come across are not being able to get that information on the fact the machine's running, but more importantly, it's idle and it's been sitting there doing nothing for a while, and the reasons why. So to measure and highlight those productivity losses and inform the right people about them. Can you make quick improvements based on unsubstantiated information? So, you need factual information to make these decisions. So obtaining consistent data in the same way across all of the different resources is key to evaluating and analysing that, because if it's all coming in different methods and different sources, it's difficult to pick up and use. So by implementing something like a monitoring solution, it can provide the information that you need really to reduce those production losses and increase your productivity, because it will help to provide a consistent data set. It will highlight your productivity, but more importantly, the losses on each of the resources. So by analysing those losses and the historic information that you collect, it can provide a focused view of the areas to address really, and therefore allow you to make improvements to reduce those losses. It can provide analysis of things like estimated versus actual time. So you can then start to see whether you're actually doing the job in the right time, or are your routing times inefficient and inaccurate, like the set and the run time, and allow you to maybe go and change that in your master routings. It will give you accurate and quantifiable information, which is what you need to make informed decisions, because how can you implement measures based on unsubstantiated information? It's all guesswork. And even though people sort of tend to think they know what it is that they should be addressing, being able to get that as a quantifiable measure and saying how much time is actually wasted is really important. So KPIs are really important measures of this, and they're key information that we need to gather. Do you know how much availability your resource has? Is the resource working efficiently and effectively? Are you delivering on time, or are you delivering a lot of work late? So by implementing these key KPIs, or the key performance indicators, you're taking the first step really to identify important information needed to help you reduce those inefficiencies and get the most from your resources. So OEE, overall equipment effectiveness, that's an important KPI to ensure you're getting the best from your machines. Because unlike utilisation, which accounts for the fact that the resource is in a productive state, but that ignores the fact that it could have produced a number of non-conforming parts. So OEE is a more accurate measure of the resource's performance because it starts to consider the availability of the resource, the performance of the resource and the quality. And then all of that comes together to calculate the OEE figure to give you the more accurate figure as to is it giving you the best from your resources. Other examples of KPIs could be things like yield versus scrap. They could be due date performance, non-conforming parts and estimated versus actual times, to name a few things. The key performance indicators should be used to assist you in the goals that you set out to achieve. So you set these goals and they should be there to help you make sure that you can get to them. So they can easily be collected, and using solutions such as the planning, the machine data collection or the monitoring and the WIP booking can help you get to the goals that you're trying to achieve as a company. So controlling your manufacturing data is again an extremely important part of this really. Making sure that the correct information is provided at the point of use is imperative to the manufacturing process. You don't want the wrong information being put down onto the shop floor. Yeah. So things that we get are control of your production information. Do you have that control? Is it paper-based maybe and not electronic? So do you send out a package of paper-based information? Do the operators have immediate access to that information? And is it the latest and most up-to-date information that they need to manufacture that part? So using electronic data deployment, it can ensure that the required information is available at point of use when it's needed. So the use of job packs, or the CT job pack as we call it in here, or a package of information through an electronic system, it provides the control of the data being used. It ensures the latest and up-to-date information, such as the correct NC programs being used. And it's all administered in the office and then accessed on the shop floor via encrypted files. So this means there's an added level of security. There's no need for this shop floor to access files and folders on your server. It's all through the software. And it provides a centralized data storage, which a lot of people think is difficult to achieve, but it's much easier to do than you think, and you can have that and have that ability. So I'm just going to hand back to John to finish the rest of the presentation.
Thank you, Neil. I just want to take you back to one of, I think it was either my first or second slide, where I talked about data accuracy and validation. So how do we make the data reliable? Well, in the CKAO system, we use prompts to the users to try and encourage them to enter the information at the point of use, so that they're not having to calculate estimated times at the end of the shift and work out how long they spent, for example, setting a particular job. We want to record the start and end of each event. We want to validate the data and make sure that it is a valid works order number, that people are booking a sensible quantity and not booking 1,000 parts because they've inadvertently hit the zero a couple too many times when they should only book 10. That way, any anomalies and errors will be not only much easier to spot, but we'll catch them early. We do that using screens like this. So on the left-hand side, we have a series of notifications. So the supervisor may get a notification to inform him or her that we had a machine that stopped on a breakdown for more than 20 minutes and we've decided that we want to be alerted. We've got an unknown stoppage. The operator is prompted to enter the reason for that unknown stoppage. And these notifications can also be generated by email. On the right-hand side, we've got a quantity of 3 to make. If you can see my mouse moving here, we haven't booked any parts, but the operator's trying to finish the operation. So we're warning them that they can't book that operation complete until they've accounted for those 3 parts, be they non-conforming or good parts. And at the bottom right-hand corner of the screen, we've got a preview of our work queue. This is what the operator would see, and information on the operation and works order that they have to carry out, the quantity required. We want to make the data timely. That was, I think, my second or third point. So how do we bring the data together for the right people in the right place at the right time? So when it's collected, We want it to be instantly available, or as available as real time as possible. We don't want to wait overnight for the data to be processed before we can see it. So we want it to be real time and easily shared amongst individuals. So here on the left-hand side of the screen, we have a work to list, the job at the top. This is the job I'm currently running. This is the next job, this bearing front with a connector under that. That's come from my planning system, from my ERP system, from the CT scheduler. But if things change, as soon as that schedule is updated, that's immediately reflected on the shop floor. So we can change anything other than the running job. The running job will not move because the operator's producing it. Until they pause it, we can't move it. But you can see we've slotted another job in beneath. And on the right-hand side of the screen is where we'd see the data to accompany that job, such as an NC program, work instructions, setting sheets, that type of thing. So that's very much an operator-centric view. This is a wider view. So the screen we're looking at now, we call this an and-on screen, and it's designed not only to be run on a desktop, but on a large screen, on the wall of an office, on a gantry over a walkway maybe. So it's giving you real-time information, so you can immediately see where you've got issues on machines. On the right-hand side, we have the ability for users of the system to send comments to each other and notifications. So here we can see an inspection comment. So somebody sent a job for first off inspection and asked the quality department to check the surface finish. Comments are typically used for shift handover notes. So the operator on the day shift will leave some notes for the operator on the night shift. So how do we make it accessible? We've collected all this data. We've focused a lot on the shop floor view there and some of the real-time screens. What about looking at things in a wider context, maybe historically as well, and looking at the trends on these KPIs? Well, on the left-hand side of the screen, we have a utilisation screen that's enabled us to look at different statuses of the resources and compare them. So we can see which resources have the biggest issues and what those issues are. Also, you can use the system on a desktop computer, but you can also use it on a tablet or a mobile phone. It's a browser-based system, so it's very easy for people to access. There's no software to be installed on any local device. And how do we share this information that we have in these disparate systems and bring it together into one system so people can use data from ERP, from planning, from design, from the shop floor, even from the actual machine or resource itself? Well, we do that by having dashboards, but these dashboards depend or are configured to suit the role of the user that's logged into the system. So if I'm an operator, I might see different information to a supervisor or director level. But taking one example here, this is the screen the operator would see. This is what we call our batch card. So you might call it a works order card, you might call it a production order card. It's a routing related to a works order. So first of all, we've got some data that we've read in from our ERP or planning system. So on the left-hand side, we've got a works order header information, so the works order number, what we're making. We've got some planned times that have come in from ERP and from the scheduling system when we should actually start and finish it. We've got information that's coming from the machine, either through digital signals or using a network connection. So how long has the machine been actually running for on this batch? How much time have we spent in setting against a planned standard time here? The operator has told us when they started this operation, so we know it's been running for just over 7 hours. We can see whether any parts have been booked and whether that operation has been completed or whether it's still in progress. We can see that it was sent for first off inspection. We can see who did that first off inspection and when it was passed. And the manufacturing information that Neil's referred to, the manufacturing data sets in the job pack system, we can actually see that as well. So set up sketches, things such as this. So now we've talked about the data and how we can present it in the system. How do we turn it into something that you can actually make use of? Well, if we look at planning, first of all, the KPIs we might be interested in here are due date performance, how many jobs actually will be delivered on time, plan versus actual times. So we want to be basing our production schedules on actual workload, the capacity we have and the efficiency of the resource, but we want to keep it up to date from the data that we've used, that we've collected on the shop floor. So this work to list, this planning board is dynamically updated so that we can then make some decisions. If we don't have capacity, maybe we do need to subcontract. out, or we do need to put on some overtime. In terms of operations and manufacturing, how can we make decisions based on evidence that we've collected, and we can, so that we build a financial justification should it be a change in process or some capital investment. So we're looking at things like, are there differences between shifts? Is there trends in our downtime? We're repeatedly getting certain downtime on resources. Are there some bottlenecks in our production in certain resources? Should we target some cost savings by looking at productivity improvements, tackling downtime causes? Is actually our non-conformance is too high, so we want to minimise waste initially. So this all comes out of things like, as Neil mentioned, OEE, but the elements of that, utilisation, quality, and plan versus actual schedule adherence. These sort of metrics are available in the system. And on the shop floor, they can contribute to this continuous improvement with using the utilisation data. So we feed the data not only to supervisory roles, but to the shop floor as well, because you will find that people will naturally try to improve the performance of their resource if they actually have visibility of the performance of that resource, and let them understand when work is supposed to be delivered, so they can see the work that they're due to get out today. So the idea is that using this data, providing and making the data accessible, sharing the data among your organisation helps people generate ideas, and quite innovative ideas sometimes, to overcome some challenges and prepare for the business, prepare the business going forwards, and especially in our most recent difficult times, maybe prepared for the unexpected. So you spend time on adding value as opposed to non-value added activities. I'm just going to close with a couple of slides here just to talk a little bit about how we can help with some of the lessons that we've learned. We've been doing this for a good while now. So the benefits of the SeaKey scheduler with the SeaKey areas, it integrates with a whole variety of different third-party systems. It's very low maintenance. Once it's installed, it'll run quite reliably. It doesn't need you to be doing anything other than generally backing up the database that sits behind it. It's scalable, so you can start in a small way if you wish to, and then roll it out. So if you have a pilot scheme you wish to run initially, you can do that and roll it out to the wider plant. The software is updated regularly. We connect to a whole host of different machines, as we've said, through resources through different types of equipment. Although our historical customer base would have CNC machines, because that was our niche market many years ago. As we've expanded the business, we have a lot of customers now that are outside of that market. So they might have plastic injection molding machines, fabrication machines, all different types of machine. And we are told by customer resource that our system is good value for money, and the flexibility, the modularity that I've discussed makes it able to implement it in a cost-effective way. So some of the lessons learned, and I've pulled out 3 key ones here, and I think this is, for me, the most important one. You need a dedicated system owner. If you're going to implement this system or elements of this system, you need somebody that manages the project, ensures that the training is properly carried out, the information is shared within the organisation, and people understand how to access the data, but also how to use the data. So we've said here maybe business improvement, Six Sigma, team leading, those type of people would be ideal to manage this project. If you're a smaller business, you may not have somebody that is your business improvement manager, or you may not have a Six Sigma scheme in your company. So you'd need to maybe train someone else, or have somebody that can devote some time to the project. The key hurdle with the implementation of this project, these type of projects, is usually capacity on the part of the end user, the customer, rather than capacity at our end. Secondly, engage with the shop floor users early on. They're going to be booking and recording a lot of the data. Get them to understand why you're doing it, what you're doing. Ask them the sort of data that they should be recording. If there's downtime codes that you're going to be looking at, then they will know what those downtime codes are. So they're the best people to ask. And finally, and this can't be guaranteed, but you may be lucky to find that actually not long after you've implemented the system, you can make a change. It might be a change in process. It may be some additional training. It may be a small investment, but it makes a difference to the people, especially the people that are booking the data. They can suddenly see their life is easier because of the data that they book, because people have acted on the results. And finally, Neil's mentioned OEE a little earlier in the presentation. I just wanted to talk here. There are many systems that are not dissimilar to Seeki, and there'll be some systems that particularly talk about OEE. I would just a word of warning, and that's nothing to disrespect the systems that do offer OEE, but a lot of them are for fast production, high volume production. So heavily used in food, pharmaceuticals, medical. We're not in that business because our system, we have a particular take on an OEE system that's designed to cater for high value parts, and a lot of our customers running low volume. So if you have a component that takes you 3 hours to manufacture, in OEE speak, your OEE is 0 for 3 hours. And if you make the part exactly on time, miraculously, exactly on the dot at 3 o'clock, your OEE shoots up to 100%. We have a bit of a unique take on that I think suits the industry better, or your type of industry better. And build your solution progressively. So maybe there's a key performance variable that you wish to act on first of all, such as downtime or on-time delivery performance. You deal with that first of all, then you can address the others as you need to. You don't have to do it all in one go. Just to explain, my final slide to explain how we do implement a system. Should you wish to go ahead in any way, shape or form with us, the first thing that will happen, normally within 2 to 3 weeks of receiving your order, we'll have a project kickoff meeting with all of your stakeholders. So it won't just be the project managers, it will be people from different departments, owners of maybe people experiencing ERP, it might be the maintenance department if we're talking connecting to machines. And from that, we will produce a document that's called a statement of work that tells you exactly what we're going to do. We both sign off on that, so you know what you should expect, and we know what we're going to deliver. EAI is an abbreviation, apologies for the acronym there, for our middleware software. So if we're integrating with a third-party ERP or other system, we'll be configuring that quite early on. We may be interfacing to machines, we may be fitting hardware in the machines to record automatically what the machine is doing, and then we'll be installing the software. Maybe 2 rounds of training, one so that you can do some user acceptance testing of the system before you go live, with the second round of training for the users that will actually use the system at that go live stage. And then we have a number of follow-up mentoring sessions. We're doing these quite successfully remotely. Pre-COVID, we would probably visit your site and spend half a day or a day, but we're finding that these are very effective actually doing them remotely now, and there may be a higher number, so we may have 3 or 4 online sessions as opposed to 1 day on site. And eventually, when you're running successfully, the system gets handed over to our support desk, so they will support you on a day-to-day basis, and your original project manager will have less direct involvement. All right, well, thank you all very much for your time. Thank you for your attendance, and we look forward to catching up with you again soon.
Thank you, everyone. Take care.
Thanks. Bye-bye.